Welcome to redding.com. In this video, we are going to see about automata. This topic covers what is automata, what is finite automata, what is the relationship between regular expression and automata, and what are NFA and DFA, and conversion from regular expression into NFA. First thing is, what is automata? These are language recognizer. Recognizer means it checks whether the particular word is belong to this program or not. It can accept the token and say whether it is a valid or not. If it is valid, it say yes, otherwise it say no. This automata exists in the second phase called syntax analyzer. We already know what is syntax analyzer. It accepts the tokens and produces the syntactic structure called parse tree. Lexical analyzer accepts the entire source program and it splits the program into single words called tokens. These tokens are accepted by syntax analyzer. Syntax analyzer checks the particular word is satisfies the source program rules, that is valid words or not. So such an operation is called recognizing operation. So the automata do the recognizing operation. So the syntax analyzer comprises the automata operation and checks whether the token is valid or not. If it is valid, then it produces the parse tree. Now we conclude the automata operation. It accepts the tokens and check if it is valid token, then it moves the next step, that is creating the parse tree. Otherwise, it produces the error. So the syntax analyzer comprises these two operations. After the output of automata, it converts the parse tree by using the parse tree generator. Now the question is how the automata checks the tokens are valid or not. In a particular programming language, these tokens are categorized into different ways that may be a keywords, identifiers, constants, strings, special symbols or operators. So these 6 categories belongs to the C programming tokens. First we can take the keywords. In C there are different keywords are there that are listed in this slide. We can easily check the keywords because these are predefined words. Using if statement, we can easily check whether these keywords are belong to the programming language words or not. Suppose these tokens may be identifiers. Identifiers forms from these rules. There may be a small a to z or capital A to z using 0 to 9 or some special characters. So the combination may be different. The variable may be declared like this: integer student underscore marks. So we cannot predict the combinations of words like keywords. So checking the tokens for identifiers is much difficult compared to keywords because keywords are predefined words, but identifiers may be the any combination words from these rules. So we should know the rules followed by the particular programming language. In C language, the identifier rules are the first character must be alphabet. The remaining characters, the combination of numbers and alphabets. No keywords are used in this identifier and it should be a single word. So these are all the rules for using identifiers in C programming language. We should follow these rules to check whether the particular word is valid or not. So now I redefine the diagram for automata. So it accepts a token, it checks the tokens valid or not by using language rules. So the automata needs another input, that is language rules. Using these rules only, the automata checks whether the token is valid or not. If it is valid, it sends to the other part, that is parse tree generator. Otherwise, it shows the error message. We can see this by simple example. While you are driving, you may checked by the policeman whether you are eligible to drive or not by using your driving license. If your driving license is valid, then you are allowed to driving. Otherwise, you are not allowed. So the policeman checks the rules and then decide allow or not. Same way, the automata checks the language rules and decide these tokens are valid or not. The next term we should know is regular expression. Regular expression is nothing but a pattern which shows the format of the identifier. For example, if I want to write your date of birth means you may write like this. First one is month name, then date, comma, then 4-digit year. Or you may write first year number, then hyphen, month number, hyphen, then date. Or you may write first one is date, month and then year. That can be separated by different special characters called slash. So you may write your date of birth for your own format. If a class have 50 students, if I say that write your date of birth on your notebook means every student can follow different formats. But I want to accept the date of birth in a proper one single format. So I should define the date of birth format. That may be look like this. First 2 digit are date, then colon symbol, then next 2 digit are month, colon symbol, then next 4 digit are year number. So if I say this is the date format means everyone write their date of birth in this same format. Such a pattern is called regular expression. Now we see the exact regular expression examples. So the identifier may be formatted like this. For example, A/B. The identifier may be A or B. Next regular expression is A star. It means A may be comes 0 times or 1 times, 2 times, 3 times or any number of times. Third one is A bar B whole star. The identifier may contains no values or A or B or combination of A and B. Next regular expression pattern is A B C star. So first 2 letters should be A B. Then C may be comes 0 times, 1 times or any number of times. So the regular expression shows the format of the particular identifier. So using regular expression, the automata identifies the rules of the identifier. So I can reform the automata diagram. So the automata accepts the collection of regular expressions. Using this regular expression, it can check whether the token is valid or not. So we can say that regular expression is nothing but the rules of the identifier, that is format of the identifier. I hope you understand what is automata. Now we are moving to the what is finite automata. Finite automata is nothing but a transition diagram for the regular expression. That transition diagram should be labeled and directed graph. In the directed graph, the nodes are the states and the edges are transitions. So the transition diagram is nothing but a directed graph. These are the nodes and these are the edges. These are labeled by A and B and the edges should be a particular direction. And the rules for the transition diagram is the node represented as a circle. It should contain a label from one node to another node. Final state should be a double circle. So this is the rules for transition diagram. Now you understand what is finite automata. It is nothing but a transition diagram for regular expression. Now we should know how to convert regular expression into finite automata. It is done by Thompson construction. So first example is epsilon. Epsilon means no symbols. It can be drawn like this. So this is the starting state, 0 state, and this is the ending state. The second example is A, that is single character. In a transition diagram, it looks like this. We can start from the 0 state and end to the first state by the label A. The third example is AB, that is first character A, then followed by the second character B. It looks like this. So we can travel from the 0 state to the end state. The reading characters are A, B. The fourth example is A or B. So the transition diagram should expose whether the particular character may be A or B. So this diagram looks like this. If we start from the 0th state and may travel in this direction and read the A and then reach the final state, or we can travel this direction and read B and reach the final state. So there is A or B. The fifth example is A star. A star means A may comes 0 times or 1 times or any number of times. That is represented in the transition diagram like this. So from the 0 state, it may travel like this. So we can read A at a 1 time or any number of time or 0 time. So this is the finite automata for A star. Sixth example is A or B whole star. That can be represented like this. We already know A or B. Using this, we can connect the zeroth state to the final state. So if there is no symbol means we can travel zeroth state and go to the end state. If we read only A means we can travel like this, or we can read A in any number of times means using these loops. Same way in B. So this transition diagram shows the A or B whole star regular expression. Next example is A or B whole star ABB. We already know A or B whole star. So the transition diagram looks like this. So this part is the A or B whole star and followed by ABB. So the combination of the identifier is zero number of A or B and it should be ended with ABB. Next example is ABC whole star. So this transition diagram looks like this. If there is no character means we can travel from zeroth state to final state. Then ABC may comes only once or any number of times for this loop. The next example is 0 or 1 followed by 0 or 2. The transition diagram looks like this. So the first part is 0 or 1. Then the second part is 0 or 2. The next example is 1, 2 or 5, 3. It is not 12 and 53. We should read like the individual character 1, 2 or 5, 3. So it should be like this. The next example is A or B, B star and whole star. So this is the complex regular expression. First we draw the simple individual parts. First we can take A or B. We know how to draw a transition diagram for A or B. So it should be like this. Then we can draw the B star separately. So B star transition diagram looks like this. Then we can combine both A or B and B star. That can be looks like this. Then we can draw A or B, B star and whole star. So that can be looks like this. After drawing this finite automata, we can check it should be satisfy this regular expression. So everything whole star means there may be a possibility for no symbols. So from zero state to end state, there should be a epsilon connection and it be repeated in n number of times. So there should be a epsilon connection from last state to first state and A or B should be there. So A or B is here and B star. So B may be 0 times or any number of times and all the conditions are satisfied by this transition diagram. You can try this last example ARB whole star, ABB, ARB whole star. You should be like this. And try this another one 0, 2 or 5, 1 whole star. So your identifier should start with 0 and combination of these numbers. This may be 0 times or any number of times. So this transition diagram looks like this. So 0 must be there and this combination may be 0 times from this state to the end state and this combination may be 1 time or any number of times. So the n number of terms may be achieved by this connection. I hope from these examples you know how to convert the regular expression into the finite automata. Now the last topic is the types of the finite automata. There are two types. One is non-deterministic finite automata, that is simply called NFA. Then second one is deterministic finite automata, simply called DFA. Non-deterministic means we cannot easily predict to the next movement. For example, if you are in a zeroth state, both the labels are epsilon. We cannot predict whether we are going to the next state is 1 or next state is 3. So there is a confusion is there. Then it is called non-deterministic. We cannot determine exactly to move the next position by means of these labels. In a practical example, the rule is if the driver have a license, then you can allow. Same way, if a driver have a license, you cannot allow. So these two rules are confusing for this policeman. He may allow for some vehicles or he may not allow some vehicles because rules are not clear. Such a condition is called non-deterministic. The rules for non-deterministic are it should be a one start state and one or more final state and should be a epsilon transition and more than one possible transition for a particular input. So this is the best example for non-deterministic. It is a one start state, one end state, and epsilon transitions are there. There may be a two possibility for this state. One is from 0 to 1, another one is from 0 to 3 for the same input symbol epsilon. So these four conditions for non-deterministic finite automata. The next one is deterministic finite automata. If the finite automata follow these four conditions, then it is called a deterministic finite automata. Here the first two conditions are same like NFA, and the third condition is different, that is it cannot be epsilon transition, and fourth condition differs from only one transition for particular input. So this diagram shows the difference between NFA and DFA. So this is the regular expression called A star. A star can be represented as NFA like this. Two or more possibility of transition from same input. But in DFA, there is no epsilon symbol and only one combination output for particular input symbol A. This is the another example. In non-deterministic finite automata, there is a epsilon symbol and one or more combination paths. But in DFA, there is no epsilon symbols. And in a particular state, there is a only possible transition for a particular input. So from A, we can move to the B for the input symbol for small a. We can move again to the A input symbol small b. So according to this input symbol, we can clearly determine whether we can move to this state or this same state. So this is called deterministic finite automata. So once you draw the deterministic finite automata, you should check whether it is satisfy these four conditions. Once you draw the non-deterministic finite automata, you should check whether that transition diagram satisfy these four rules. So in this class, we discuss what is automata, what is finite automata, what is regular expression, what are NFA and DFA, what are the conditions for these two, how to draw regular expression into NFA. I hope this class is very useful to you. Thank you.